These are the frequently asked questions for pre-calculus for section P5 day 2, starting with number 22. And on number 22 it says solve the equation using the quadratic formula. And we have x squared minus 5 equals the square root of 3x. Well, to use the quadratic formula you have to have a 0. So you're going to have to subtract the square root of 3x from both sides. And here's where it gets awkward. Our a is a 1, but our b is a negative square root of 3, and our c is negative 5. So x equals negative b, which would be the negative of negative square roots of 3, which is the square root of 3, minus the square root of b squared. Well, that's going to be negative square root of 3 squared. So that will be negative square root of 3 times negative square root of 3, which would be a positive square root of 9, which is just 3, minus 4 times 1 times negative 5 for AC, all over 2a. And a is 1, so 2 times 1 will give us 2. X equals the square root of 3 minus, well, we have 4 times 5 times 1, which is 20, but 2 negatives here is going to make that a plus. So 3 plus 20 is the square root of 23. All over 2, and oops, there's our little plus minus piece in there. And that, of course, would be an exact answer, and we could go ahead and put that into the calculator if we would like, and x comes out to approximately 3.264 when you punch in the square root of 3 plus the square root of 23, all of that divided by 2. And remember, you really need those parentheses in order for that to come out right on the calculator. And then you can hit second enter and change that plus into subtraction, and that will give you negative 1.532. Next on your list is number 38. In exercises 37 and 38, use tables to find the indicated number of solutions of the equation accurate to 2 decimal places. So for 38, they want our graphing calculator, and they want us to find one solution that is going to be accurate to 2 decimal places. So y equals, on your graphing calculator, a negative x to the third plus x clear this out. There we go. Negative x to the third plus x, and then plus 1. And I'm going to hit zoom standard, and we'll hope we get to see an intersection here because it said we had to find one. Well, we see one, and it looks like it's a little bit to the right of 1. So I would go into my table and take a peek and see, well, yeah, we've got at 1, it is 1, 1. At 2, it's 2, negative 5. So 1, 1 is above the x-axis, and 2, negative 5 is below the x-axis. Then we could go into second table startup and start it at 1 because we know it's between 1 and 2, but go by hundredths. Actually, you might want to go just by tenths first to get a good read for where it's at. Second table, it did appear to be closer to the 1 than the 2. So now we see it has to be between the 1.3 and the 1.4, because at 1.3 it's above the x-axis, and at 1.4 it's below. But they wanted 2 decimal places, so now we're going to start our table at 1.3 and go by hundredths to get in even closer. And we see that it's between 1.32 and 1.33 because, again, we have a positive value for our y's with 1.32 and a negative with 1.33. And they do want this accurate to 2 decimal places, so we should really go to thousandths so that we can make that happen. So we're going to start at 1.32, second table start, And we'll change this to thousandths. And then we will be able to look at our table. And now we can see, just waiting for the calculator to catch up here, that 1.324 is above the axis and 1.325 is below the axis. So then we try to figure out, well, how far off are we talking here, so we'll know which one we should really use. And in this case, we have a 1.324, and that is at 306 hundred thousandths. And then the 1.325 is at 12 thousandths. So what we want to do, actually 10 thousandths, sorry, 100 thousandths and 10 thousandths there. So what we want to do is figure out, which one of those is closest. And I just keep thinking all you have to do is look at the decimals here, and you'll see that in the third decimal place for 1.324 we have a 3, and then in the third decimal place for 1.325 we have a 1. So we would go with 1.325, but they said to round to 2 decimal places, so 1.33. All of that, just to find the decimal places. When we could have just done second trace, number 2, much more efficient use of our time, and find the zeros. So let's see where Blinky comes up at. And we'll set Blinky here and here and enter through, guess, and we get 1.3247, which of course would round to 1.33. So again, it's much more efficient to use the zero feature on the calculator, but that's not what they wanted us to do. They wanted us to do the table. So we did the table, and we did find the answer that we needed. All right, now these say use a method of your choice to solve the problem. So 48 x squared minus 3x equals 12 minus 3 times the quantity x minus 2. Well, let's distribute, let's get it all over on one side, and let's see what we're dealing with here. So be careful distributing that negative 3. You don't want to lose track of your signs. X squared minus 3x equals negative 3x plus 18. Well, if we add 3x to both sides, those are going to drop out, and we will get x squared equals 18. So our answer will be the square root of x squared, which is a positive and negative, but we can simplify the square root of 18 and make that the square root of 9 times the square root of 2. So plus or minus 3 square roots of 2 as an exact answer. But if we went ahead and punched that into the calculator, x will be approximately 4.243, and x will be approximately negative 4.243, because it's a positive and negative. And as far as punching it in goes, probably easier to just punch in the square root of 18. You won't have to do the multiplication piece for the 3 square roots of 2 that you need there. And you'll get your answer a little faster on your calculator. Next one is 50. All right, I'm already starting to solve the problem. So I take a look at this, and I see that this has a square root. And if you remember from Algebra 2 last year, whenever there is a square root involved in the problem, you want to isolate it. You want to get it by itself. So we're going to add that to both sides and see what happens. And that will give us x plus 2 equals 2 square roots of x plus 3. Now, solving with roots is not a lot of fun, so let's square both sides and get rid of that. And 2 squared is 4, and the square root of x plus 3 squared is x plus 3. So x squared plus 4x plus 4 will equal 4x plus 12. So interesting again how our x's are going to drop out. So if we subtract 4x from both sides, those are gone. And we have x squared plus 4 equals 12. We would subtract 4 from both sides and then take the square root. And x equals plus or minus the square root of 8, which if we're going to leave that in exact form, that would be plus or minus the square root of 4 times the square root of 2, which which is plus or minus 2 square roots of 2. And again, they generally have us figure out what these are with a calculator anyway. And it's a really good thing to use your graphing calculator to check this one anyway, because whenever you have square roots and you're squaring or raising to a 4th power or 6th power to solve the sides, you might get an extraneous solution. And in this case, we do. Negative 2 square roots of 2 does not work. So it is a positive 2 square roots of 2, which if you put that on your calculator is approximately 2.828. Again, reminder from Algebra 2 that whenever we raise something to that even power, there's always the possibility of extraneous solutions. So if we put this into the calculator, and actually we could have just put it in exactly like this into y sub 1, we would see we're getting 1 0 out of that that's usable. So we go ahead and use that 2 square roots of 2 as our solution to number 50. Number 51. 51 is x cubed plus 4x squared minus 3x minus 2 equals 0. And you know me, I'm always going to go for solving it by hand if I can. So I try grouping, and I realize it's not going to work. I'm not going to see x plus 4 as a factor in negative 3x minus 2. So next thing I would try would be, hey, maybe if I change the order, that'll help. Well, I can pull an x out of these two. That'll give me x squared minus 3, but that's not going to help me with the back part. So this one is not factorable by grouping, which means we do need to use the graphing calculator to find the zeros. So with this one, it's just a matter of plugging it in and seeing what they are. So y equals, in this case, we have x to the 3rd. And then we have plus 4x squared. Again, I need to go a little slower so I can be sure the calculator's punching in what I am pushing in. Minus 3x minus 2. And zoom standard. And we can see all 3 of them here. So second, trace, and number 2, zeros. We need to figure out where Blinky is, and Blinky's way down there at 0, negative 2. So I'm going to have to hit my left arrow several times to get Blinky back to where Blinky needs to be. Now Blinky is below the axis, and I press enter, and then I hit the right arrow until I'm above and press enter. So there's the first one. Negative 4.562 approximately. Let's go back and get the others. Second, trace. Number 2. And let's get Blinky in position for the middle 0. But this time Blinky is going to have to be above because that's to the left of the intersection with the x-axis. And we press enter, hit the right arrow until we get below it, enter through guess, approximately negative 0.438. One more to go. Second trace, number 2. Fortunately, this time not very far to go, but again, below the x-axis so that we're to the left. Press enter. Above, press enter. Enter through guess. And that one is at 1, 0. So that is 1. And actually, I'm not even going to put approximately. It is 1. Now, if we were to go back and try to factor this and find the exact solutions, here's what we would know. 1 works. We saw that graphically. So if you remember, we would want to verify that synthetically. We have 1x cubed, 4x squared, a negative 3x, and a negative 2. You bring the 1 down, you multiply the 1 and the 1, and then add inside the box. Multiply outside the box, add inside the box, multiply outside the box, add inside the box. And then what we have left here is a quadratic. It's x squared plus 5x plus 2 equals 0. And that's not factorable. And the reason we know that is because of these two right here. So we can do completing the square or the quadratic formula with that and get those additional two solutions exactly. But that's not what this lesson was about. This lesson was about making use of all of the things that we know so far. All right, number 56. Now, on number 48, or number 50, I should say, this is the one where I squared both sides to get rid of it. So I look at 56 and I think, well, what about, squaring both sides? Well, you're okay on the left, but on the right-hand side, you're going to have an x to the fourth. And we don't have any methods for solving those x to the fourths unless it's something that works out perfect. So I give it a try. And that will give me x plus 7, and over here, negative x squared plus 5 times negative x squared plus 5. And x plus 7 will equal, first times first would give us a positive x to the fourth, outside times outside, a negative 5x squared, inside times inside, a negative 5x squared, and last times last, a plus 25. So x plus 7 equals x to the fourth minus 10x squared plus 25. Get everything over to one side by subtracting an x and subtracting a 7. And again, we can try and factor that, but the only way we would have to try is factoring by grouping, and it doesn't work. So the best thing to do for this one is just to leave it exactly as it is. Put this equation in as y sub 1, put this equation in as y sub 2, and find the intersection. That's going to be the fastest and easiest way to get these zeros. So we clear this out, and we put in the square root of x plus 7 and then negative x squared plus 5. And let's see if Zoom Standard is going to give us a good enough look at that one. So there's the first graph. That's our square root graph. And we can see there are two solutions here. So this time it would be second intersection, second trace number 5. And I do want Blinky to do that left one first, so I'm going to move Blinky into a better spot so that Blinky knows, hey, I want the left intersection. So there's my first answer there, and that is, and I just covered it up, negative 1.6, hang on, 38. So 3, 8, and then we've got, for our y coordinates, 2.136. And then we need the second intersection. So second trace number 5, but we have to move Blinky over near that right-hand intersection and enter, enter, enter. So that one, 1.447, 2.906. So the intersection feature working a lot better for that problem. Next up, let's see, where do we go from here? That was 56. Number 57. Actually, this is what we just talked about in class today. Discriminant of a quadratic, the radicand b squared minus 4ac, and the quadratic formula is called the discriminant of the quadratic polynomial ax squared plus bx plus c, because it can be used to describe the nature of its zeros. So A says, writing to learn. If b squared minus 4ac is greater than 0, what can you say about the zeros of the quadratic polynomial, and explain your answer? Well, there's your discriminant, but we don't necessarily bring the square root along with the discriminant, but this is what you have to think of as you're going through this problem. If b squared minus 4ac is something that's greater than 0, we are going to be able to find the two zeros because the quadratic formula has that plus or minus in front of that. So there will be two real solutions with b squared minus 4ac as a positive value. We can find the square root of b squared minus 4ac. And then I would just tack that little plus or minus piece in front of there because that's telling us, hey, we're going to have two of those solutions. B says, how about if it comes out to be 0? All right, so you do your little b squared minus 4ac, and it comes out to be 0. Well, that again is because it's hitting the x-axis. It's a tangent at that point. So you get one real repeat 0. This is because plus or minus the square root of 0 is just 0. So we get one real repeat 0. And then part C says, how about if it's negative? What's going to happen? Well, that's what we spent a lot of time talking about in class today. We will have two imaginary solutions, or you could say complex conjugates, because plus or minus the square root of a negative number will create imaginary solutions. So a little reminder of the discriminant in that problem. Then number 60, John's paint crew knows from experience that its 18-foot ladder is particularly stable when the distance from the ground to the top of the ladder is 5 feet more than the distance from the building. All right, so this last problem, we have a right triangle. And when we have a right triangle, we can use the Pythagorean theorem. And we have x squared plus x plus 5 squared equals 18. So that will be x squared plus x plus 5 times x plus 5 equals 18. X squared plus 10x plus 25 equals, oh, forgot my little squared symbol for that one. So 18 squared over there. And that will give us 324. And then we subtract the 324 and just kind of bring everything together here, and we will get 2x squared plus 10x minus 299 equals 0. And because they didn't give us a method, the best thing to do with this one is to just go ahead and punch it in and find the 0 that makes sense. Chances are pretty good we might get an extraneous solution on this one in the negatives. So what we're going to do is just punch it in and find that real 0. So 2x squared plus 10x minus 299. And zoom standard. And we can see the calculator's working. And what that tells us is, we just need to wait a little bit, but we can see it's just barely off the screen. So if we go into our window and we maybe change our x values to 20 here and graph it, we should get a much better look at what's going on. Just takes it a little while. And I watched while it was graphing and saw that it graphed from below. So second trace, finding the 0, I'm going to have to make sure that Blinky, which is now way down there at negative 199, I'm going to watch until that gets close to 0. And it's coming up fast. And it's the y value, and there it was. So Blinky's below, I press enter. Blinky's above, I press enter, and enter through guess. So you really have to use the screen down there for this one. And for this one, we have 9.979, so 9.980. And that would be in feet.